ClimateAction.tech is a community of tech professionals with the goal to inspire and empower each other to take climate action. And without further ado, Asim, over to you.
So welcome to talk on green software engineering, building kind of carbon efficient applications. So yeah, thank you very much. My name is Asim Hussain. Asim.dev is my website, and I'm what's called the Green Cloud Advocacy lead at Microsoft. I'm in, I used to think of myself, as green. I used to do kind of a lot of the things that I thought you needed to do, but then I had an epiphany a couple of years ago with my son, and I realized that, I was willing to do a lot of things. You're having cloth nappies with him at a time. And so I was basically willing to deal with cloth nappies and poop and shit and all this other stuff which you have to deal with when you deal with cloth nappies. But then I'd realized why was I willing to deal with that? And yet I had never really looked at, investigated, explored what are the ways I could be green in my job, in software engineering. How do you actually build software that's green? What does green even mean when it comes to software? So that started me on a long journey, which eventually, I'm very lucky to say, turned into a role at Microsoft, which is kind of green cloud advocacy lead. And it's all really about trying to figure out what it even means to be green, but then growing this field that we're starting to call kind of green software engineering or sustainable software engineering, and kind of really that approach. A lot of it actually just really started with ClimateAction.tech. So I joined, I can't remember actually when I joined, a couple of years ago now. And you're all part of CAT, you know what it's like. And I started asking questions inside there, realized a number of other people are kind of asking the same questions, and a lot of people definitely pointed me in the right direction. Did a lot of studying, learned a hell of a lot, but then I realized after about 6 months, it's just not good enough. I now understand a lot, but I can't expect the next person to spend 6 months learning what I've learned. Took a massive leap of faith in that I actually had something worthwhile saying, and kind of worked with others to kind of create what's called PRINCIPLES.GREEN, which are a set of what I consider to be 8 first principles. So these are the things, sat down and thought, well, what are the things that you need to know in order to be green in software development that you're just not taught? They're not taught in any kind of coding workshops or universities or anything like that. They're not taught. You're not taught them, full stop. What are the things you need to know? And really trying to condense it down to just the essentials. The idea was like, you can just drop in, learn what you need to learn in about 30 minutes, and then kind of go about your day job and hopefully apply some of this stuff in your day job. And that's kind of where Principles.Green was born, and it's kind of eight principles, things you need to know. So Principles.Green, I work at Microsoft, so we have now since kind of moved this to Microsoft Learning, which has just, all that really means is somebody made some nice diagrams instead of you having to look at my hand-drawn diagrams. That's pretty much the difference, but this is pretty much the same content. And I also create a blog in Microsoft called the Sustainable Software Engineering blog. Super proud of this, actually. It's super grassroots, and I really see the value of a blog. It's kind of brought people together who from all walks of life inside Microsoft, all areas, Xbox to research to hardware, kind of sitting together, talking and writing stuff. So I've also started writing some docs as well. Anyway, so there's 2 philosophies. Before we dig into kind of green software engineering, I like to kind of preface it all with talking about the 2 philosophies of green software engineering or sustainable software engineering. And a lot of it is to So I think a great way to describe this is there is a report by an advertising agency called Ogilvy in 2010 called Mainstream Green, and it tries to break down what the green audiences look like. And this is 10 years ago, or 11 years ago now. And how they broke it down was, 16% of people define themselves as super green. So I would argue everybody on this call and everybody who's now a member of CAT would identify themselves as super green. So these are people who are kind of aware of the climate crisis, and we're dealing with it. We're trying to do something. We know it's bad, and we want to do something to solve it. Then you've kind of got these middle greens that kind of, they care about it, but maybe they won't actually do anything about it. Then you've obviously got the green rejectors, which are the climate deniers. And the way I describe it is that it would be really useful to me. So I'd say that this is what you look at it: 16%, and this is 10 years ago. I'd argue this is more like 20% now. 16% of all engineers, all tech workers in every single area of technology care. They're super green. Whether you're front end, back end, middleware, machine learning, design, database, doesn't matter where you are, because you're scattered everywhere. 16% care about this stuff, and it would be super useful. It'd be really useful is if we could if I could control all this whole 16%, and kind of this year I could say, okay, all 16% of you in the entirety of the technology this year, it'd be really useful if you could focus in on moving everybody to green clouding hosts. Okay, next year, now it'd be really useful to optimize databases next year. But that's not how this world works. This world works because everybody is kind of just spread out all over the place. And I think that's kind of the I felt personally, that's the problem that there's been in kind of these endeavors in the past, is that, and I can talk about from a Microsoft perspective, you end up just talking in a company or in an organization, you end up just wanting to, classically, we've just spoken to the one or two people who can actually make a difference or who can make the biggest difference. And we've given them advice, and we've spoken to them. And that's a problem, because it means that the rest of the 16% of people have nothing to do. And that's not how you create change in organizations, by speaking to one or two people. To create change in organizations, you speak to everybody. And that's kind of why the first philosophy of green software engineering is everybody has a part to play. So the goal of this competing discipline is to give advice to, and best practices and patterns to everybody. Whatever your domain, whatever your area, there is something, and there will be some advice for you. There is something for you to do. So everybody's a part to play. That's the first philosophy of green software engineering. And the second one is just that, sustainability is just enough all by itself. Like when I oftentimes when having conversations with people, and it goes on to the argument, well, how do we actually start convincing people to adopt this practice? Well, then oftentimes you then fall into the argument of, well, it's also cheaper. Okay, let's forget about talking about sustainability. Let's just talk about cost, because that's an easier argument to have. Or actually, I just realized green software is actually faster than gray software. Let's just start talking about performance as an argument to get people to adopt it. And that's also a problem, because then people lose the motivation for why they're doing this. I mean, there are loads of advantages to building green applications. They're always cheaper, they're almost always faster, they're almost always more resilient. But that's not the reason why we're doing this. We're doing this because sustainability is our goal. All these other things are an added advantage. And there's kind of two philosophies that I like to talk about when we talk about green software engineering, because I think it's really important to kind of define the culture of what we're trying to create here. It's a cultural change. But anyway, I'm going to dig into kind of a couple of the principles. I'll go on for 20 minutes, and then wherever we are, I'll just pause and we can start answering questions, because it will take me an hour or so to go through all of them. So let's just go through them as we go along. And again, you can find all of this at either principles.green or acad.m, whatever the Microsoft link was. It's far away. So the first one is carbon. So that's quite interesting. When I first started looking at stuff, like what does being green mean when it comes to a piece of software? I work at Microsoft. Microsoft, we think of sustainability on 4 pillars: carbon, waste, water, and ecosystems. When you look at the United Nations sustainability goals, there's 17. And which one are you optimizing for when we talk about sustainability? Like, what are you trying to make better? It's really hard to optimize for 4 variables. It's really hard to optimize for 17 variables. So with green software engineering, we're focusing on carbon, essentially emitting less carbon, right? There's other things you can do. You can think about how your software uses data centers and uses how those data centers use water, and whether that water is being stolen from regions and population which need it to survive. You can look at it from a biodiversity. You can look at it from other perspectives. We're just focusing on carbon just to get it out of the way. That's the actual focus and goal. The way I'm going to speed through this stuff because I normally talk about this stuff, give this presentation to people who perhaps aren't so knowledgeable, but I'm going to assume that there's a certain amount of knowledge here. So I'd normally explain the climate change. I'm not going to. We know carbon. When we talk carbon, I talk carbon. Go on.
Why would there be why would data centers use water?
Oh, cooling.
They don't have closed loop. They'd be like pulling outside water.
Oftentimes, yeah, normally a lot of this stuff is both cooling and also in power plants as well. Like the cool water comes in, it heats up, and then they just chuck it back out. It's drinkable, but it might not be good for the environment, and it might not be good for other reasons. But yeah, that's one of the reasons.
Interesting. Thanks.
And that's why one of the kind of data centers designs that kind of look at where they don't use water for cooling is really important. It's better from an energy perspective, but it's also better from a water perspective as well. Because you also don't want to you end up using drinking water, because you don't just want like river water like going through
it's
your
like
data
sticks
center.
and stuff.
Yeah, yeah, exactly. Yeah. Yeah, so it's carbon dioxide. Another way I kind of think about it when we talk about what we're trying to achieve is waste. I think waste is a really good term to use because it kind of galvanizes and frames the conversation in a really good way, which is not to waste carbon. My attitude is that no matter what we do, everything we do, we emit carbon. And so our goals in life is to, for every gram of carbon that we emit, just get the most value out of it that we can. That's what we have to achieve. And I give a great example here of internal combustion engines versus EVs. Like why is one green and one not green? There's very different reasons why electric vehicles are green. But here's a great example. So you look at the energy from oil. To turn oil into petrol or gasoline, you lose 50% of the potential energy of that material is just gone. It disappears. It's thrown in. You can't use it. It turns to heat or whatever it turns to. Must be heat. And it weighs something. So to get that petrol to a car, you lose another 20%. And then to get that, an internal combustion engine is only about 20% efficient at turning the energy from petrol or gasoline into forward motion. So it's 8%. So that's the challenge, if you think about it, with fossil fuels, is that we're throwing away 92% of the energy in a fossil fuel for a car. If you can imagine a world in which an internal combustion engine or the whole process can be made so it's like 90% efficient, I think we'd be living in a very different world, and we'd have a different relationship with fossil fuels. So, it's just such a wasteful emitter of carbon. We're getting such little, well, you're getting a lot of value out of it because it's so energy dense, but there's a lot of it's wasted. Take a look at an electric vehicle. You can say you get 100% of the solar energy because whatever that sun was either going to hit your roof or it's going to hit the ground. So there's nothing getting wasted. So you're getting 100% of it into a solar panel. You only lose about maximum 2% traveling long distances to get that electricity into your car. And it's about 70% efficient at turning the energy from your battery into forward motion. So that is why I argue an EV is green. It's just more efficient at turning energy, getting useful operation out of energy. And so that's kind of the way we think about it is we call building applications that are carbon efficient. Our goal as green software engineers is to build applications which emit the same or less carbon, but still add the same value or functionality to the end user, being more carbon efficient. And the really interesting thing is that if you actually start thinking about your applications this way, there's plenty of things you can do, or the things that might perhaps options that might appear to you for you to achieve this without having any impact onto your end user, just because you've never thought about it before from that angle. The second one is like, yeah, no, okay. So the other one is the second principle is electricity. And this was because this was quite a learning experience for me, my learning journey to this whole process as well. I used to think that electricity was clean. Like you don't think of electricity as dirty. When you plug something into a wall socket, like there's no smell in the room. Your hands don't get dirty. It's not like opening the lid of your car or like cleaning something else is obviously dirty. There's no kind of evidence that electricity is dirty from how you consume it at home. So it gives this false idea that electricity is quite clean. But in fact, electricity is really, really dirty. It's one of the dirtiest things on the planet. 49%, I think, is the statistic of all the emissions in the world are created from well, it's electricity and heat, but it's the biggest kind of single source of emissions out there, and that's because most electricity is still created through the burning of fossil fuels. Coal is the common one, and quite dirty coal. And so, it's really, so that's why I think what amazed me was that I knew nothing about electricity. I mean, I'm an engineer. I use laptops every single day. My career would be nothing without a computer and a laptop. And I didn't understand the thing that powers it. I mean, it might as well be, magic juice for however much I understand it. Like it literally might as well be magic. It might as well be magic for how we, how I understood it. And I don't think that's right. Like as an engineer, I should understand kind of what electricity is, how is it used, how is it measured. These are important things for you to understand as a green software engineer as well. I think the key things to understand is kind of how you measure it. So there's a couple of different ways of measuring it. So the term you might hear a lot is kilowatt hour. And kilowatt hour is a volume of electricity. So a joule is a volume of electricity. A watt is a flow or power. 1 watt means 1 joule per second. A kilowatt is 1,000 watts, so it's 1,000 joules per second. And a kilowatt hour is, if you let that run for 1 hour, what is the volume of electricity you would get at the end of it? So kilowatt hour is a measure of a volume of electricity. And at this point, I'd just like to, because I talk about electricity and I talk quite negatively about electricity, I'd just like to spend a second just to explain. Electricity is a big part of the problem, but it's also a huge part of the solution as well. So global world consumption of energy, all types of energy, not just electricity, all types of energy is 18 terawatts. And now we know a terawatt is a flow. It's a flow. So it's kind of a per second flow. That is a global, worldwide consumption of energy. That's the flow. And we're destroying our planet for 18 terawatts, basically.
And Asim, where do we get that number from?
That one I got one, I think, is Wikipedia. I think I got that one from. And the second one I got from a book called Sustainability Without the Hot Air. Energy Without the Hot Air. Sustainable energy without the hot air. So cool. This next one is, but the total available energy from wind is 1,000 terawatts. I mean, to get that, you'd have to capture every single gust of wind on the planet, but there's 1,000 terawatts available from wind. But there's 173,000 terawatts available from solar energy. Now that would be a solar panel the size of the Earth, but there's 172,000 terawatts available from solar. So this is kind of why, like, electricity is a huge problem, but it's also kind of a huge potential solution, because look at what we have available to us. Look at the amount of energy that we have available to us, way more than we have right now, just by moving to cleaner sources of energy. So electricity is not a problem. It's part of our solution as well. That leads to the second principle, which is to kind of build applications that are energy efficient. So anything, if your goal is to be carbon efficient, if you can draw a line between something that you're measuring back to carbon, then it's kind of related. So because we can now draw a line from electricity back to carbon, therefore our goal is to be energy efficient. Okay, so we want to be energy efficient. The third principle is carbon intensity. Now, I listen to this podcast. I love listening to this podcast. I recommend listening to this podcast. It's called the Energy Transition Show with Chris Nelder. It teaches you. It's the only podcast I've ever paid for, and it's the only podcast I've ever gone to episode 1 and listened all the way through. It teaches you a lot of things. It talks about the energy transition that's happening right now in the world, from fossil sources to renewable or clean sources. And it taught me a lot of things. One thing it taught me was carbon intensity. So now some of these terms are going to start to make sense. So all electricity is somewhat clean and somewhat dirty. It kind of depends what's coming out your wall socket. It kind of depends on the energy sources in your area, in your grid. If you have a lot of coal burning power plants, it's going to be more dirtier. If you have a lot more renewables, it's going to be a lot cleaner. That measure of how clean and dirty electricity is carbon intensity. The unit of measurement of carbon intensity is grams of carbon per kilowatt hour. Now we know a kilowatt hour is a volume of electricity. Kind of makes more sense. The global average for, I think I might be quoting this number for so long, it might be for the wrong year now, but it's either 2019 and 2020. Was 519 grams, about half a kilo of carbon per kilowatt hour. If you're trying to visualize what half a kilo of carbon looks like, imagine half a kilo of soot or ash in your hands. That's what we're talking about. And it really depends, because as I said before, it depends on where you are in the world. So we've got electricity maps here. It's kind of a great service. They have a literal map, which is very, very useful to visualize a lot of this stuff, where you can hover over different countries and different grids and different regions. It tells you what the electricity is right now, and how clean and dirty it is. That again depends on what is the default. Maybe just Australia has a lot. Northern Australia has a lot of coal producing power plants. So does the East Coast US, and you can see Poland. Other regions like France is very, very green. But that's actually mostly because France is mostly nuclear. So there's various different reasons. But so that's one thing to think about. It's kind of, well, you know, you could literally run your software in a region which is just powered more by renewables, right? Even if it's not a data center that's 100% powered by renewables, if it's literally located in a country which is mostly got very clean energy, France has very clean energy almost on a consistent basis because it's all nuclear, it's going to be a hell of a lot better than if you ran that in like India or Australia or East Coast of US. It's quite bad as well, depending on the grid. So that's one choice that you can make. But the other thing about carbon intensity is it also changes over time. So it changes by region and also changes over time, just because of the nature of how things work. Like there's not a lot of storage in the grid. So what that means is if I turn on my kettle at home, they have to do this balancing so that the utility literally has to burn more coal or find more energy to service my kettle at that instant in time. There's no buffer system so they can kind of scale up and scale down. There's this kind of instant on-off demand thing. And what this means is a couple of different things. Well, the challenge with wind and solar is you can't control it. When the wind is there, it's great, you've got free energy, but the wind can die down and the sun can stop shining. But that demand is still there. And if you don't meet that demand, you get a brownout because the frequency goes down. So what they do is they then burn more coal and burn more gas, because you can control coal and gas. You can just quickly ramp it up to meet that demand. And that's this constant balancing thing that utilities are doing all the time. But it's also why over time, the carbon intensity of electricity changes. It can be quite clean, maybe at some time of the day, and then another time of day, it can be quite dirty. It changes over time. So there's various different sources of data for carbon intensity. If you're based in the UK, there's carbonintensity.org.uk, which is 100% free. You don't even need a login or API key. There's What Time, which is a US-based nonprofit, which provide that data, and again, they have APIs. And there's Electricity Map, which they're based in France, and they have another API as well. To get that data also. There's various different sources of carbon intensity data that you can look at, which kind of give you, for a given region, for a given grid, how clean or dirty is that electricity at this moment in time. And they can also give you different projected data. So they can say, look, based on our analysis of wind patterns or something, we think that tonight between 2 and 4 p.m. it's going to be very, very, very clean, or tomorrow between 1 and 3 it's going to be very, very, very dirty. So they can kind of give you that projected stuff as well. And that's the third principle of sustainable software engineering, is consume electricity with the lowest carbon intensity, right? You can do different things. You can run your computing workload or something in a place that's cleaner, or if you have a batch job, or if you just have a process that's kind of latency in what's called insensitive, like it doesn't really care, it can come back in 5 minutes or 10 minutes or an hour or by tomorrow or something. Maybe run that at a time. That's better. Maybe run it at a time and a location that's better, right? Kind of you can move around spatially and in time as well. And that gives you some really interesting ways to solve this problem. Moving to the third principle, fourth principle, I'm going to just stop at this one, I think, afterwards. So this is me giving a talk at a conference, which are these things that used to happen before COVID. With a lot of people in the room. Shocking. Look at the social distancing there. Oh my God. But this is way well before COVID. So as you can tell there, I was giving a talk on climate change. And it was an earlier version of this talk, I think, much earlier version of this talk. And I remember at the end of these conferences, I'd like stand to the side at the end of the talk, and I'd usually get a bunch of people after my talk would kind of walk up and ask me questions, and I'd kind of spend a while answering questions. I remember this at very conference. There was a guy who waited, must have been half an hour, waited patiently to speak and ask me a question. Then all he said was, great talk, but I couldn't believe a word you said because you used a laptop that was built in China, and then stormed off. And it was very confusing because the whole China comment like really confused me for a while. But basically what he was, I chased him over, I spoke to him later, kind of grilled him what he was talking about. He was talking about the fact that how dare I talk about climate change by using a device that emitted carbon into the atmosphere. But you know, that's kind of the arguments you get that are interesting. But he's not lying. There's a term called embodied carbon. So every single device in the world, everything, created carbon in its released carbon in its creation, and will release carbon in its destruction as well. And that carbon is called embodied carbon, and it's very, very, very significant. For my mobile phone, especially since the UK is fairly clean electricity, the carbon emissions from the electricity that I will use to charge this mobile phone for the entire life of the mobile phone will probably not outweigh the carbon emissions it has already emitted from just existing. For a server in the cloud, it's a different equation. The equation is a lot more flipped. Electricity has a bigger impact, depending on where you are in the world. But it's also an interesting challenge, because what does that mean? Like, it's very significant, it's important. But as a software engineer, so what? What does that mean to me? How do I change what I do to take this into account? And I think the interesting angle for that is to look at like the lifetime of hardware. Like, a lot of the time when you're throwing this away, it's usually not because it's broken. It's usually because you want a better one that's faster. The same goes for server hardware. I mean, servers, they do break down. They definitely break down. But the vast majority of them, there's no like moving parts. There's no spinning disks anymore, right? So they just exist. The vast majority of them, you just end of life them. Right? It's like, well, we can get more money in that space in a data center by putting another server in. We worked out the maths, and it's just better for us. Or like, no one wants this server anymore. No one's buying it. They just always want to buy the best one. So let's get rid of it. Same with hardware. Same with laptops. Same with everything. And so what you tend to do is you tend to take like the how much carbon something released in its creation, its embodied carbon, and you spread it out over time for like what you expect the lifetime of that device to be. A server is 3 to 5 years. So if it's 4 tons to create, you then say it's kind of like 1 ton a year, or like 80 kilograms a month, or something like that. Oh, there's an actual worked example for one server. So the embodied carbon of this specific server is 1.2 tons. If you assume a 4-year lifespan, you say that's 320 a year. Assuming, I think I use the EU electricity mix, and assuming it's kind of running at 100%, it's 486 kilograms from the electricity. So the yearly total, 806 kilograms per year. So that's kind of how you calculate it for that one, assuming a 4-year lifespan. And so 40% of the yearly total is from the embodied carbon. So it's significant. It's not nothing. It's significant. But what if we just made our hardware last longer? Right? There's no reason to throw this away. The only reason that we throw it away is because we're constantly writing software which is making this stuff obsolete, right? We're just making this stuff obsolete, and our software is not necessarily better. We almost just become lazier and lazier and lazier programmers because our hardware gets better and better and better, and we can get away with lazier code. Until eventually people just have to throw away things all the time. So can we amortize? Can we just lengthen the lifespan of hardware? And if we were to just take the same example and assume a 5-year lifespan, that reduces the embodied carbon a year. The electricity is the same. and it kind of reduces the impact of the embodied carbon. It's a complex thing, but it's also embodied carbon is quite significant. This is one of the ways that I think that as software engineers, you can have an impact with respect to embodied carbon. Otherwise, the equation is kind of very lopsided. I think at this point I'll leave it. There are other so that's why the principle is build applications that are what's called hardware efficient. Again, hardware emitted carbon. So hardware is linked to carbon. So if our goal is to be carbon efficient, our goal is to be efficient with hardware, right? So that's one way of thinking about it. There are like other principles. Energy proportionality is a really good one. But there's kind of 4 other principles that you can research and learn and figure stuff out. Let me. Yeah, if you want to find out more information, we've got some stuff there. And there was a conference a while ago called greenconf.io. It does have some nice. It was the first conference on sustainable software engineering, on green software engineering. So it's got quite a few talks on there. If you go to greenconf.io, you'll find the talks. There's a bunch of people talking there. And that's it. So at this point, are there any questions?
Yeah, I just want to jump in. If there's any questions that you don't mind asking that'll be on the recording, just drop them in now, or please just come off of mute and ask. And then once we die out on that, then we'll switch off the recording to see if there are others. Please ask away. I haven't seen the whole talk in a while, so I'm gonna go and watch it again. Does anyone have any questions?
Really good presentation, Asim.
Awesome. Thanks a lot.
I had a question for you, I guess, about there's a whole bunch of stuff, but I thought that was interesting, the comment about magic. Because there's this quote from Isaac Asimov, I believe, like any sufficiently advanced technology is indistinguishable from magic.
Yeah. The more you dig into electricity, the more I dig into electricity, the more I realize that my assumptions of how I thought it worked are completely wrong, and how it works is so much more magical than I could have ever possibly imagined. It is incredible.
So I guess, like, assuming that humans are going to persist on the earth, like we're going to solve climate change, we're not going to get boiled off the face. Like, is it possible to have 100% renewable grid?
Talk about just energy.
So like using like maybe like lithium batteries, potential energy batteries, wind and solar, and just supplying the grid that way.
I think that should be the target that we aim for. Whether or not you'd reach kind of like 100%, I don't know. Maybe we'll get to the point where it's like 98% or 97%, and like the last couple of percent, it just isn't worthwhile to go after, or there's various reasons. Like fossil fuels, for all their flaws, are extremely energy dense. If you live in the kind of area where it just doesn't make sense to, you just don't have that capability, maybe we'll get to that point. But I think it's a target you should aim for, absolutely. And I think we can get very, very close to it. Very close to it. Yeah.
Brian, you have a question?
You had the comment earlier about the importance of including that middle set of folks who aren't, highly familiar with this topic, but still concerned. And I totally agree with that. And it sounds like you give this talk to multiple groups of people. What arguments have you found really, effective? What part of that talk really connects with people? And for those of us in that top small percent, what's the best way we could include those people?
So you're talking, I think you're talking about kind of that middle band of people, and actually my argument is that you don't have to. What you need to do is you need to convince the decision makers. Okay, you need to convince the decision makers. So my advice on that front is on two levels. Is that nothing's ever going to happen unless somebody that you're speaking to cares about this space, right? They're going to have to care about this space. You're never going to convince one of your managers who does not believe in climate change, or or who does but doesn't really care enough about it to really invest in something here. So if that's somebody that is the person you need to convince, my other piece of advice is there's always a bigger fish. So just keep on going up higher in the chain, and you'll almost certainly, well, not almost certainly. I work in a large organization, so there's a lot of people between me and the CEO. So if you keep on going up that stack, like, you'll typically find someone who is willing to support you. And then my second piece of advice is give them something, give them an argument that they can use to defend their decision to support you. It's different from giving them an argument which they can use to convince others of the same position that you have. Just give them an argument which allows them to defend their position to support you. Frankly, my argument that I pitched for myself here is just, look, it's a competitive advantage for Microsoft to be in this space. You know, we've got competitive advantage over Amazon. Microsoft is always constantly like trying to figure out how do we one up Amazon. There's like a constant battle going on there, and that's what I presented. It's enough of an argument. It's not a solid argument, but it's enough of an argument for them to defend their decision to support me. And that's all they have to do, is defend their decision to support me. That is how I look at it. And the other thing is there's a really great book, and I'm going to forget the name. It really helped me a lot. It's the morals. Oh, I'm forgetting it. It's going to kill me now. I'll post it in the thing later. But it's about moral psychology, which is not a topic I normally read at all, ever. But it was recommended to me a while ago, and it talks about the kind of the 5 moral dimensions with which people make choices, and how people on the left and kind of climate activists very, very, very much lean on this kind of what's called a care harm dimension, which is kind of want to reduce harm in the world. But other people who are more right-leaning actually make decisions on other moral dimensions, and one of them is authority and subversion. And so getting somebody in senior leadership to put a stake in the ground and say, this is something that's important. I've seen people who I know are climate deniers get behind this and support it 100%, because they don't want to subvert leadership, right? So there's a lot of interesting angles on that to go on, but yeah, there's a lot of tricks to employ. Yeah, does that help?
Yeah, definitely. Yeah, thank you. I think I slightly misinterpreted that slide, but what you said makes sense. So thank you.
Yeah.
Matthew, you have your hand raised. You want to jump in? And then we have a couple of questions in the chat, Asim, too.
Okay.
Yeah, sure. Hi. So I'm coming from a slightly different place than most of you, since I've spent the past 8 years working as a building physicist, sustainability consultant, sort of engineer, sort of in the built environment. So the big focus over there is now, firstly, that, you know, it's been wonderful that particularly in the UK we've turned off our coal, electricity's got much greener, but the single biggest focus is all about reducing the amount of energy we use. The focus has been entirely on reduce, and I'm coming to software as and what I can't help but notice is that no matter where I turn at the moment, the amount of data being transferred and used just is exploding. I mean, you read sort of in the news that Bitcoin suddenly, just the power consumption behind Bitcoin alone is larger than the power consumption of small countries. And, you know, or down to sort of smaller things like my new mobile phone by default will suddenly take an entire series of burst photos rather than one. So suddenly 20 times more data than it originally would have stored. And every single website seems to download so much rubbish that you don't actually need. How do you think that sort of software as an industry can start to say, look, this is enough. We've actually got to reduce our data input, our data footprint, not just worry about, then trying to make sure it's served by green electricity or make sure we have the right hardware. How do we make sure that fundamentally the product that we're delivering is as low impact as possible?
I think that's I think the question you're asking, I'm going to interpret it as top down.
Sort of how do you go from a culture shift where data is kind of free and impactless to a culture where by generating data in itself is an act of creating carbon and has an environmental impact? And how do we get rid of that bloat and so focus on just what matters?
So that's kind of what the dream and vision is of what we're trying to grow with kind of green software engineering, sustainable software engineering. As I describe it, is we need to change the culture of software development. We need to make it so that when people are describing or figuring out, so the person who's the team that sat there and said, oh, let's do 20 burst photos instead of 5. You know, there needs to be someone in that team meeting that puts their hands up and goes, well, look, there's benefits to this. I understand there's benefits to this. There's a marketing benefit. There's this and that, the other. Have we evaluated and measured the sustainability cost, the green cost? There's always, that's the way that I think we're going to get the biggest change. Is it needs to be driven by people like us, and we need to grow it. Top down is a much more difficult one because then you're expecting like companies to commit. So from a Microsoft perspective, because we have publicly committed to something, it's possible for me and people inside Microsoft to say, well, look, I don't think we should do this because it's going to increase our emissions. And that works. If you're part of an organization which hasn't committed to anything, that argument's not going to hold water. But if you are part of it, if you have a culture of asking these questions in tech meetings, then I think that's kind of the only way that we're really going to make that kind of change. Is we just need to have it, make that culture. I describe it as like, now we have a culture of security in software engineering. Now we have a culture of testing in software engineering. Now we're getting a culture of accessibility in software engineering. These are kind of questions which it's not like you're not challenged when you say like, well, you still are challenged when you say, let's add a test case to something, or let's add this, you know, let's add some testing, your quality assurance or something. But it's not as bad as it used to be. We just
but
you're challenged
with green. You're challenged equally. Like, that's equity. You know.
Yes. Yeah. It should be the same. Like, we should be. And I think that's another thing is we can't demand to be the most important voice in the room, because to other people, accessibility is the most important voice in the room. To other people, security might be the most important voice, you know, in the room. We should have an equal stake in that argument, and we are not there yet. We're not there yet, but that's just what we need to get. We just need to have an equal stake in that argument. Yeah.
And Matthew, also, like, don't worry too much that like your code like is going to like lead to like out of control global warming, because there's like, as Asim said, like there's embodied carbon in the actual hardware, and the electricity, that's a really small amount. So.
Don't worry, from my background, I realize that, but it just feels like there's not the culture of that. It doesn't feel like there's the culture. It doesn't feel like there's that culture yet.
There can be, though, I think, because software engineers love efficiency. And at the end of the day, like, that's really all, you know, green software is, just
The ultimate vision, sorry.
And I was just going to follow up on with a question in the chat that's quite similar and quite a good follow on from this. But if you wanted to add another point.
I've actually forgotten what I was going to say.
Okay. So I have a question that was seconded. As users of technology, servers, data centers, etc., how should we best exert pressure on technology providers to supply us with green products to build software on?
So this is kind of like the green by default thing. It's really difficult, to be honest with you, because how do you exert pressure? I think if you're a large organized,
I think they're referring.
Go on.
I think they're referring to sort of like how can a consumer make sure that like the Apple laptop they buy is good.
The only way a consumer's voice will be heard is if it's in aggregate with a lot of other voices, unfortunately. I have seen, although I think perhaps the easier way, or the way that has the greatest people are motivated by fear. Yeah, people are motivated by two things: fear and greed. I believe there's two things: fear and greed. You can say to a company, essentially, look, you will earn more money if you do it this way, and then they will perhaps kind of go in that direction. Or you can trigger the fear response, which is like you will either lose money or other things will happen if you don't do this response. The problem with the retail approach is that you need a lot of people to come together, because if one person says that, a company just goes, well, okay, I've got 993 million other people that will still buy it. So, okay. Where I think is really interesting is I've seen policy. Oh, am I still there? Saying my internet connection is unstable. I'm going to take my camera off. I've seen policy, the threat of policy, be extremely effective inside organizations, far more effective than either the carrot of money for doing things in a greener way, or the stick of losing money if you don't do things in a greener way. The threat of a policy change in an area drives a lot more changes. So so if you can do something the best thing you can do as a retail person is to help some way drive policy changes. Demand for standardization, demand for all of your software to report their energy metrics real time to you, demand for, these are the kind of things. And I think the best way you're going to use your voice is to make sure this happens at the policy level. But yeah.